Hello everyone. In this video, we're gonna learn how to model the exponential functions given data sets. Now, before we're gonna jump into the example number 1, let's take a moment to review the exponential function. Alright, so the exponential function is given by the formula y equals a times b raised to the s, where a is the initial value, the y-intercept, y-intercept is where s equal to 0, keep that in mind. B is the common ratio. Alright, now let's jump into the example number 1. We need to model the exponential function given the data sets right here. So we observe that we see that there is no relationship between these two outputs, right? So that we need to manipulate to create a relationship between two outputs. Alright, so how do we do that? We need to sketch the additional column. We call this is f of s minus 1, right? So if we take 7, we subtract 1, we get 6. 13 subtract 1, we get 12. 25 subtract 1, we get 24. 49 subtract 1, we get 48. 97 subtract 1, we get 96. Now, if we multiply 6 by 2, we get 12, right? Multiply 12 by 2, we get 24. Multiply 24 by 2, we get 48. And multiply 48 by 2, we get 96. Alright, so we have the same common ratio, and this is actually b. So b equals 2, right? Now, we need to find the y-intercept. So y-intercept is where s equal to 0. We look at the second row right here. Okay, so y-intercept is where s equal to 0. So y-intercept equal to 6, right? S equal to 0 right here. Okay, so we have the exponential function as follow. Now, the exponential function in this situation is not f of s. It must be f of s minus 1 right here. Alright, so we have f of s minus 1 equals a which means the y-intercept, which is 6 right here, times b is the common ratio right here 2. Okay, right to the s like this. Alright, so we need to solve for f of s, so we need to add 1 both sides. So f of s is 6 times 2 right to the s plus 1, right? And this is the answer for the first table. Now, let's move on to the second table right here. Alright, so we see that there is no relationship between these outputs, right? So we need to create the new column. Now, what if we add each output right here by 2? To see what happens. So 2 plus 2 is going to be 4. 10 plus 2 is going to be 12. 34 plus 2 is going to be 36. 106 plus 2 is going to be 108. And 322 plus 2 is going to be 324. Alright, 4 times 3 to get 12. 12 times 3 to get 36. 36 times 3 to get 108. 108 times 3 we get 324. Alright, so the common ratio right here, b equals 3. Now, y-intercept is where s equal to 0. So s equal to 0 here, y-intercept right here, 4. Alright, so we start with g of s plus 2. Right, so it can be g of s plus 2 equals a times b to the s, a equal to 4 times b, which means 3 raised to the s, right? So we need to solve for g of s, so we need to subtract to both sides. It's gonna be 4 times 3 to the s minus 2, alright? Now let's take a look at the last one right here. Alright, so we see that there is no pattern among these outputs, right? So in order to create a pattern among these, we need to create the new column. Alright, so what if we add 1 to each output right here to see what happens? So we have h of s plus 1. Alright, 63 plus 1 is going to be 64. 31 plus 1 is going to be 32. 15 plus 1 is going to be 16. 7 plus 1 is going to be 8. 3 plus 1 is going to be 4, right? So, we see that in order to get 32 from 64, does that mean we need to multiply by 1/2, right? And this one, multiply by 1/2. So every single time, we're going to multiply by 1/2. So 1/2 right here is the common ratio, right? So b equals 1/2. Now, we need to find the y-intercept, which is a, right? So y-intercept where s equal to 0. So s right here equal to 0 right here. Y-intercept must be 64, right? So we have h of s plus 1 right here equals a, which means 64, times b, which is 1/2 raised to the s. Alright, now we need to solve for h of s. So h of s equals 64 times 1/2 raised to the s minus 1. Or we can rewrite this one as 64 times 2 raised to the negative of s minus 1, right? Now let's move on to the example number 2. So we scatter table, right? So we have 2 minutes, and then it's gonna be 47 people. If we have 20 minutes, it's gonna be 2,602 people, right? Okay, so we're gonna bring up the calculator to create the exponential regression for this problem. Alright, so first I'm gonna use the TI-Nspire calculator, and then I'm gonna use the TI-84 plus C calculator. So I'm gonna bring this one up. Alright, so the first thing, I'm gonna go to home screen right here, right? So I'm gonna add number 4 right here, list and spreadsheet, right? So I'm gonna input the value right here. I need to move up to name the columns, right? So right here, and I'm gonna name this is S column, and this one, and this one should be Y. All right. So I move my rectangle to the plane right here, okay? And then I'm gonna hit menu, number 4, start calculation, and then it should be exponential function. So I'm gonna move to A right here, exponential function. Alright, so S list I put S, and Y list I put Y. Alright, right here, my function will be stored as F1, right? Move down, hit OK. Alright, so this is my exponential function, which is y equals 30.089 parentheses. The common ratio is so 1.250 to the t. Alright. Now the second method, I'm going to use the TI-84 plus C calculator. Alright, so I'm going to hit start, edit, Alright, so I'm going to input the data, right? If you see the data right here, you just move the cursors over here and highlight the whole column and hit clear, go down, it's gone. This one same thing, go up, clear, go down, it's gone. Now you just input data. So data right here should be 220, right? 2. So you hit start again, go to count, right? Go to linear, go to exponential function regression, which is 0 right here, right? Hit enter, right? L1, L2, which is X list and Y list. Now go to store regression right here. You need to go over here and hit vars, Y vars, function Y1. Alright, so my function will be stored as Y1. And then go down, hit calculate, and I get the same answer right here. 30.089, and this is 1.250, right? So it's gonna be exactly the same thing right here. Alright. Let's move on to the next example. Alright, so given the function b of t equals 17e to the 0.31 t. Alright, so we know that e right here, this is the natural base. So e is going to be approximately 2.718. Now question A. Let a of t equals a times b raised to the t be an equivalent expression for b sub t. Alright, now we need to solve for b. So basically we just equate this one, right? So we have a of t equals b of t. So we have a times b raised to the t right here must be equal to this one, right? So it could be 17 times e to the 0.31 t, right? Now we just match them up, right? A equal to 17 and b raised to the t equals e raised to the 0.31 t, right? Now we can solve this one. So we have a equals 17. Alright, we just match this one up. B equals e to the 0.31, right? Now question B. Find the average rate of change of b of t over the interval from t equals 1 to t equals 7 hours. Alright, so we have the formula of the average rate of change. It's going to be f of b minus f of a over b minus a, right? So it's going to be b of 7 minus b of 1 over 7 minus 1, right? The interval from 1 to 7, right? So b of 7 is going to be right here. So we have 17 e to the 0.31 times 7 minus 17 e to the 0.31 times 1 over 7 minus 1, which is 6. Alright, so we're going to use a calculator. We're going to get the answer, right? So I'm going to hit Control I. Add calculator right here. Alright, so I have, and then hit enter. So the answer must be 20.9521, right? So you just round this, so it should be 20.952. Alright, let's move on to the question C. Find the number of bacteria B predicted by the model after 15 hours. So 15 hours, which is t equal to 15, right? So we just substitute over here. So we have b of 15 equals 17 times e to the 0.31 times 15 right here. All right, remember 15 is on the exponent, right? So we can bring up the calculator right here. Answer must be 1777.94. Now question D. Find the value of t when the number of bacteria is 1000. Alright, so basically we have 17 e to the 0.31 t equals 1000. Alright, now we have two different ways to solve this one. Now the first way, we need to graph the function f of t equals 17 times e to the 0.31 t. And the second function g of t equals 1000. And then we need to find the intersection. So we hit Ctrl I, add graph right here. So first we're gonna wrap this one right here. Alright, so we're gonna hit Ctrl I. We're gonna add graphs right here. So we input 17 times e to the 0.31 times s right here, because the function f of s, right? Alright, so we hit enter. So we see the graph right here. Okay, if we want to see the whole thing, we just drag this one. We see the whole thing right here. Okay, alright. Now we need to put this one right here on the same x and y coordinate plane so that we see the intersection. Alright, so we bring up this one again. We hit tabs right here. Now we input 1000. Alright, so we hit enter. Now, if we hit enter, we don't see the graph because this is 1000. And then look at this one, it's just 12.08. So we need to adjust the window. So we hit menu right here, window, zoom right here. And then we just hit this one right here, zoom fit. Alright, so we scroll down until we see 1000 right here, this 1000 right here. Alright, so we need to find the intersection right here. Now we need to hit menu and number 6 right here, analyze graph and intersection right here. We need to move the vertical lines to the left of the intersection. We know that the intersection right here. So move to the left of intersection, hit enter, and move to the right of intersection, hit enter, and then you will see that the intersection right here. It's going to be 13.1, right? So t equals 13.1 hours. Now, what if we use a TI-84 plus C calculators? So we hit y equals. Now I need to clear this one. Alright, so I input 17 times e. E is going to be right here. So I hit second e to the s right here. And I input 0.31 s. Alright, the second equation right here, I need to input 1000. And I just hit graph. If they don't show up, you need to hit window right here. You need to adjust the window, right? For the s value, maximum and minimum right here, I put -10, and this one I put 20 because I know that the s value must be around 13 or something like that, so I put 20. Now for the y minimum, that's good. For the maximum right here, I need the number greater than 1000, right? So I put 1100. Alright, the scale for the y right here, okay, I need to put like 50. Alright, or maybe 100. And I hit graph. Now I see the intersection right here. Okay, so I hit second trace right here. Number 5 right here, intersection. Then I hit enter 3 times. 1, 2, 3. And the intersection right here. It's going to be 13.1. Done. Now let's jump to the last example. Example number 5. So we see that the function is modeled by the exponential function right here. D sub t equals a times b to the t squared. T represents the number of years since they were first introduced to the rooted errors. So the first time they were introduced is 50 years, right? So this is the y-intercept or initial value, which is the a value right here. So a equal to 50. Right, now we need to solve for b. So we know that initial value is going to be 50. Now every single year the population of the increase by 13%. Alright, so next year it's going to be equal to the initial value plus 50 times 0.13, right? Because it's increasing by 13%, right? So I'm going to factor 50 out. So I have 1 plus 0.13, right? And then it's going to be 50 times 1.13. And then 1.13 right here. This is my common ratio. This which is b. Alright, so a equals 50 and b equals 1.13. And then the function should be d sub t equals 50 times 1.13 to the t. Alright. Now question B. According to the model found in part A, what is the population of deer in the large wooded area after 6 years? So we just substitute 6 years over here. So we have d of 6 equals 50 times 1.13 to the 6 right here. And then we hit the calculator. Alright, so we hit Control I, add calculator here, and we hit 50 times parenthesis 1.13 close parenthesis to the 6, right? So it could be to the 6 and hit enter. So the answer must be 104.098. 104.098 dear, right? Now next question. Find an equivalent expression for this of t squared t each measure in months, right? So basically we have the function right here. This of t is 50 times 1.13, right? T right here, this is in years, right? So 1 year has 12 months. So basically we just divide this one by 12. Now question D. We need to find the time t when the population is 5,000. Alright, so we do exactly same thing in the example number 4. So we're gonna hit Control I. So we hit add graphs right here. Now we input the value right here, which is 50 times 1.13 to the t, which is s. Okay. And then we hit enter. Right, the graph should be right here. Now we need to wrap another function y equals 5,000, right? So we hit tab right here, and then we input 5,000, and we hit enter, and then it doesn't show up. So we need to hit menu, window setting right here. Now we need to adjust this one right here. We need the Y max right here. It should be more than 5,000, right? So we hit clear. We put 5,100 right here, okay? And we hit OK. So we see that the graph is coming right here. It's right here. And then we hit menu, analyze graph, intersection, move the vertical line to the right of intersection. And the intersection right here should be 37.7, right? So T equal 37.7 years. And if we use the TI-84 plus CE calculator, we're going to bring this one up. So we hit Y equals. Now we need to change the function. It should be 50 times 1.13 raised to the S, right? Okay, and the second one right here must be 5,000. Alright, so we hit graph. Now the 5,000 doesn't show up. We need to hit the window right here. Now we need to adjust the window range right here. The Y max right here should be 5,100. Alright, and we hit graph. Now it show up right here. But it doesn't show up to the right? So we need to adjust the S value. So hit window right here. The S max right here, I need to hit 50. Right, I hit graph. Now it show up right here. Now I hit second trace intersection right here, number 5. And I hit enter 3 times. 1, 2, 3. The answer is 37.68, right? So it's similar to this one. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand